Okay, so in this video, we will introduce the idea of linear approximation, but first, we will give an intuitive way to obtain the equation of the tangent line to a function at a given value of x, say x0. And the idea is to look at two different ways to obtain the slope of the tangent line. So first, since we have a line, we can find the slope of the line by choosing on this line two distinct points. Well, first we have the point x0, and let's call the corresponding y value y0. And then let's take an arbitrary value of x and the corresponding arbitrary y value y. Now that we have 2 points on the line, we can easily find the slope. The slope, of course, is the ratio of delta y versus delta x. Delta y is y minus y0. And delta x is, of course, x minus x0. So now, the slope of the tangent line is, of course, the change in y over the change in x. The change in y being y minus y0. And the change in x being x minus x0. But there is another way to find the slope of the tangent line. If you recall, by definition, the slope of the tangent line to the function f of x at the point x0 is the derivative of the function at the point of tangency x0. So two separate ways to obtain the slope of our tangent line. And now, when we want the equation of the tangent line, we are looking for expressing y in terms of x. Well, this can be easily accomplished if we now, from this equality, simply isolate the y value. So first, multiply across the equality by x minus x0. So then y minus y0 is f prime of x0 times x minus x0. And finally, to isolate for y, add y0 on both sides. And so y is equal to y0 plus the derivative at x0 times x minus x0. And we can now make one last observation. If you look at the y value y0, it is not only a point, a y value for the tangent line, but also the exact y value of the function at x0. So y0 is also f of x0. So we can now make the substitution. So the equation of the tangent line to the function f of x at x0 is given by f of x0 plus the derivative of the function at x0 times x minus x0. So we now have found the equation of the tangent line to f of x at an arbitrary point x0. So this is step 1. If you have a function f of x, and you look at the tangent line to this function at the point x0, y0, the equation is simply given by the value of the function at x0 plus the slope of the tangent line, the derivative of the function at x0, times the change in x, x minus x0. So this is part 1. Now, with this, we can discuss the idea of linear approximation. And the idea is remarkably simple. If you notice, near the point of tangency, the y values on the tangent line are very close to the y values on the function. So around the point of tangent C, the tangent line serves as a simple yet good approximation to the values of the function. So what this says is simply the y values on the function, if you look at say, this point, So this is f of x. The y values on the function are very close to the y values on the tangent line, which are given by this equation. So f of x is approximately this. F of x0 plus the derivative at x0 times x minus x0. But it's clear from the picture that the closer x is to x0, the point of tangency, the closer the y value on the tangent line is to the y value on the function. But as we let x move further away from x0, then it's clear that the gap between the y value on the tangent line and the y value on the function is getting bigger. So we only have a good approximation between the y values on the function and the y values on the tangent line if we stay close to the point of tangency, so if x is close to x0. And this result is known as linear approximation. And again, to summarize, it is a very simple result, which says, as long as you stay close to the point of tangency, so as long as you take a value of x close to x0, the y values on the tangent line, given by this, will be very close to the y values on the original function. And that's it.